Now we have almost understood the UPS in detail, but before going ahead we should know electrical ratings and real meaning. See, understanding what the numbers actually mean, it is very important to understand those numbers so that you can interpret it, relate it, and take your own decisions. Okay, first is kVA versus kilowatt. Okay, finally demystified. Okay, so real difference, kVA is equal to apparent power. It looks like it is real power, but it is not. It is apparent. It appears like a real power. So it is called apparent power. It is not real power. Voltage multiplied by current. If you multiply voltage to current of any device, taking current and voltage, then you get the kVA, apparent power. Rather VA I will call it. K is kilo. Okay, means 1000 multiplied by 1000. The total capacity UPS must handle in kVA, total capacity. Now kilowatt. Kilowatt is the real power, actual work done. Okay, what the load consumes exactly. Whatever power is consumed by load, that is kilowatt. Okay, relationship, kilowatt is equal to kVA multiplied by power factor. Now example, 100 kVA UPS with 0.9 power factor is 90 kilowatt only. It can support to 90 kilowatt load, not 100 kilowatt load. Okay, 90 kilowatt. So it is defined by this factor, power factor. Now modern IT loads typically 0.95 to 0.99 power factor. Older equipments are 0.7 to 0.8 power factor. So modern equipments have good power factor. Okay, so 95 to 99, which is good for us. Then it will not affect the size of our UPS. Otherwise, if it is 0.7, then it will become only 70 kilowatt. Then we need to install 100 kVA UPS for 70 kilowatt load. 30% will be wastage. But as IT equipments are coming with very good power factors, our sizing will not become huge. Okay, so that is the difference. Now real sizing mistakes. Okay, mistake 1, using only kilowatt for sizing. No, don't use kilowatt. Ignoring kVA. A 80 kilowatt load at 0.8 power factor needs 100 kVA, because 100 multiplied by 0.8, it becomes 80. Then mistake 2, assuming UPS can deliver full kilowatt at any power factor. No, UPSs are kVA limited first. Now mistake 3, not verifying actual power factor before sizing. You should verify, you should know your load. What is your load? What is their power factor? If it is inductive, capacitive, reactive, what kind of load? 3 loads are there: inductive, resistive, capacitive. You should know its power factor. So nameplate ratings lie. If you go on nameplate ratings, you will have wrong calculations, because you need to check, you need to put the power factor meter online and check the power factor before doing this. Nameplate rating lie, measure real consumption. It is very much important. And then size your UPS. Load diversity myths. Now what is load diversity? What is diversity? Let us say I have this television, okay, screen, and then what? This air conditioner, lighting, everything is there, but I am using it at a time when I am not doing this lecture. Okay, I am not recording this lecture, then I am not using this lighting, not using, maybe I will be using air conditioning but not screen. So this will be diversity. I will be using only air conditioning while I am taking rest. Okay, light I will not be using. So all the roads will not be working all the time. Okay, that is diversity. Means, let's say 100 is our full load, then all the time you will find 50, 60 or 70% load is working. Other loads are taking rest because they are not used. They are connected load. Okay. Now Myth, 100 servers multiplied by 500 watt is equal to 50 kilowatt. No, you have 100 servers of 50 watt, that doesn't mean you got a 50 kilowatt load. No, diversity factor will be there. So I need 50 kilowatt UPS. Reality, diversity factor 0.6 to 0.8. 60 to 80% load will be working all the time. It's typical, it is typical, but you cannot rely on diversity for critical loads. No, take a bigger size UPS. Don't rely on this thing. Otherwise, what will happen if all the roads are switched on? Your UPS will come down. What if all servers spike simultaneously during backup or maintenance? FMs whose size UPS using diversity factor create time bombs. Okay, it will explode, capacitors and all, you know how it happens. So always size for 100% simultaneous load unless you have years of monitoring data proving otherwise. So size for 100% load, no matter. Sizing should be always at the higher side. We have seen the sizing formulas. Okay, the rules, thumb rules of sizing. So always size for 100% load simultaneously. Though you will have bigger UPS, but this is catering to very critical load, and that is okay to spend more money on UPS. Okay, so that is why don't go on diversity myths. Okay, now just to understand this kVA, kilowatt, and apparent and real power, we will just see the power triangle. Okay, here power triangle, the real power rating representing actual energy consumption, that is kilowatt. This is what your electricity meter measures. It will not measure kVA, it will measure kilowatt and what you pay for it, money. Okay, so modern IT loads have high power factors 0.9 to 1, making kilowatt and kVA ratings nearly equal. But what is kVA and kilowatt difference? So this is a power triangle. You see, this thing is kilowatt and this thing is apparent power, slanted. Okay, this slope is apparent power, kVA, and this is kilowatt. Now what is this which is affecting or which is making it larger, kVA? This is a kVAR. Okay, it is called reactive power. This power is not consumed. This power is facilitating the consumption. Now let's take an example of inductive load. Okay, let's say induction motor or induction cooking, anyway. So what does it do? It will increase the reactive power. Okay, so for what? To create the magnetic field in the winding, okay, or induction of magnetic field, it will require power, some power. But when work will be done? When it is moving. So whenever this motor is moving, that is actual work done. But just facilitating for the magnetic field, that also requires some amount of energy, and that is reactive energy. See, that energy can be compensated by putting a capacitor. Okay, power factor correction. Okay, APFC, automatic power factor correction panel you must have. The capacitors are there, switching on, switching off. So what happens there? See, capacitors are energy storage devices. We know that. It will store the charge on the plates. See, in first cycle, capacitor as well as this inductive coil is getting charged. This will create magnetic field. This will hold the charge. Okay, so even for magnetic field also is kind of energy. Now in next cycle, what happens? This thing, see, this happens in half cycle. When direction changes, the energy exchange happen between this. Okay, direction changes. In one direction, this will charge. In another direction, this will charge. So this will give energy to capacitor, and capacitor will give energy to inductor. So this rotation will happen. So this is a compensation of reactive power. Okay, and then this point will come here if you have 99, and then your actual power and apparent power become same. Okay, so this is a simple fundamental behind this reactive power or power triangle, we call it. Okay.